All right, here we go. Yes, that was me at Christmas. Okay, all right. So here's a video on F10 day one inverses. Hey, when I say inverse, you say domain and range exchange, or in my class, we say switch X and Y. So trying to get my pens to come up there. Now we're ready to go. Yes, an exponential is an inverse of a logarithm. When I say inverse, you say switch x and y. So this becomes x equals b to the y. And then the only way I could change this, well, the way one of the two ways is just change it to a logarithm. So base, hey, look at this. Answer, exponent, all by its lonesome. All right, so that's how an exponential is actually an inverse of a logarithm. You literally switch x and y on the exponential and then resolve for y through changing that exponent to a logarithm. All right, you could go ahead and look at all this, follow all these directions, because that's exactly what I'm going to do here. So we're just going to go right into the math. When I say inverse, you say switch x and y. 3 times 2 raised to the y plus 4. I almost made that x again. Boo-boo there. All right, and then I have to resolve for y. I got to get this all by itself somehow. Well, things I got to do first is add 15. I mean, I can't really help you on undo operations. And then this 3 times, you want to divide by 3, and I'm going to allow that. You can leave that in, just that fractional form when we deal with the next part. And what is the next part? The next part is I have my 3 positions, 1, 2, 3. So one way we could do this is change the exponent to a log. I'll show you whatever I do to one side, do to the other on number 2. So in my class, I made a stupid little video of a sound. And that noise is changing an exponent to a log. So the base goes here. The answer goes here. I want to make sure I did that right. I get my pen. It's hard to do all this. X plus 15. This is the definition of a logarithm, you my silly little friends. All right, and then this becomes the exponent all by itself over here. Oh, I didn't get this color coded. So that is what a logarithm is, a repositioning of the 3 positions of an exponential in this case. Then all I have to do is subtract 4, and then I'll turn this into the inverse notation. So subtracting 4 leaves me with, just leave this as a division statement. This is what I was blabbering about before there. You're fine. And then we're going to leak into this next question with this minus 4 on the outside. Okay, so that is separate from the logarithm. That is outside of the logarithm argument. The x plus 15 divided by 3. Okay, and then that's it. I don't know if they ask you anything else, domain and range. So that might be a little bit tough, but minus 15. Well, we'll just move on. They didn't ask for it, so I'm not going to blabber about that. Okay, I'll change colors. Cowboy baby. Lassoing this. Get this out of the way. Of course, now that's in the way of this one. Yeah, I just screwed up. All right. We'll just move that over a little bit. Okay, now green. Okay, same thing. When I say inverse, you say domain and range exchange. Switch X and Y. Couldn't care less what sentence you use there, it's the same thing. Subtract 7, divide by 4 again. You have 4 times plus 7. So subtract 7 first, then divide by 4. You're in a high-level math class. You should understand those undo operations. Now, actually, I got a cowboy again because I was going to say this one, I'll attack whatever I do to one side, I do to the other. What would you do to both sides? You would ln both sides. I literally hit the pen. I love technology. So I'll ln both. Why did that just go away again? ln both sides. Okay, so we are in a similar position there. And then what happens here is ln of e raised to the y minus 1 just ends up being y minus 1. These literally do cancel each other. That's another way of looking at it. Or another way. And then the last thing I have to do is add this 1 to both sides. And then I guess I'm staying red because I don't feel like changing the colors. Divided by 4, and then add 1, and then that's how this y is by itself. And now we're going to turn this into inverse of f of x. All right, so pretty simple, pretty standard. And then it's just the reverse when we have logarithms turning into exponents. So we'll do that 2 different ways. Okay, so finding the inverse of this logarithm. When I say inverse, you say, and then this is y minus 4 plus 6. And then what you got to do is isolate this. So I have a plus 6 and multiply by negative 3. So I'm going to subtract 6 and divide by negative 3. And feel free to leave that as such. Pen's acting wonky. There it goes again. We keep losing connection. All right, and then I have my 3 positions. Can be whatever I do to one side, I do to the other. Base for that whole thing. Well, I need that because I got to get rid of that plus 10. We should be understanding. I love technology. Love it. Okay, so we have this now, and then the last thing I have to do is subtract 3 and divide by 2. Now this may be messy. Let's subtract the 3, and then I guess we could divide by 2 and just leave it like this. You could put a half out in front, so it'd be a half e raised to the x minus 10, and then minus 3 halves. But I don't think, I think this is good. H inverse. I know it was H up there. Yep, okay. All right, acceptable answer. Okay, and then what do we got for here?